Okay, good evening, everybody. Let us start our lecture today. Today is November 18, 2021, and as usual, so let us see our syllabus. And we are almost at the end of this semester. So today's lecture. After that, there is a break, and after that is a review. So, if you have any problem that we can review. So in the review section, we may not need to come here. We can join online. Okay. So today's and last topic is Np Completeness. Okay, is an interesting topic and is an important topic. Is not only for computer science. Is in many areas, research areas, computer science, math, statistics, business, religion, you say politics, whatever you say, or medical science. Okay, so if you can contribute something in this area, in this field, then it will be helpful for a lot of people, not only in computer science, maybe the whole human community may be benefited from this research. So tonight, actually, what I am going to do, I will share my understanding, what I understand about this topic, and then let us do a collaborative talk for this one. We started the entire semester, right? I spoke a lot in the entire semester, but tonight is for you. Okay, and let us both together. And then, as I said, that I will. This is the most confusing, important, and most confusing and difficult topic. So many students and many people they confuse something. So I will try to give you some anecdotal examples based on my understanding and how do I understand and how did I understand and how I remember this concept. Even I don't need to see the slides. I can talk this, but the slides are for you, and I uploaded the slide in G12. Okay, so NP Completeness is a research topic in many areas, not limited in computer science, as I said. Okay. So far, we have learned that there are some algorithms, many algorithms we have learned, right? In this course, mainly we learn how to analyze an algorithm. And the concept is the target is to analyze an algorithm. That means while analyzing an algorithm, we would learn how to write a good algorithm. Okay, a better algorithm. Okay, so far we learned that there are mainly two types of algorithms. Some of them can be solved in polynomial time. Polynomial means is either big O n, either big O n or big O n squared or big O n cubed, okay, or constant time or big O n log n or whatever to say. These are the constant. These are not constant. These are actually polynomial time. Okay, and there are some algorithms we saw that, for instance, 0-1 knapsack problem. If it can, we try to solve it in naive way that it takes 2 to the power n times. In our last lecture we discussed, right? And there are some other algorithms. These are non-polynomial time algorithms. So in case of large n, okay, sometime for a large n, 2 to the power n will be greater than n cube or n to the power 5 or n to the power 10. Right? So for every algorithm, our goal is to write polynomial time algorithm. And sometime polynomial time, we say our goal is to write deterministic algorithm. Deterministic algorithm means whatever we write our algorithm, we understand that what is happening, we understand. Either we memorize or even we do not memorize, if we see our book, we understand that there is nothing ambiguity. Okay, you see that all algorithms, whatever is discussed, right? Is there anything ambiguity? No. All statements are straightforward, and then this is called deterministic. Okay, but so deterministic problem, there are some, these are called, this is not a single problem, a set of problems. Okay, that is denoted as P, or you can say DP, deterministic polynomial problems. That means the problem that can be solved in polynomial time, either big O or constant time, or one of these, like this. Okay, and if a problem cannot be solved like this way, that is called non-polynomial. Okay, or even cannot be even verified, either solved or verified. Okay, then the is called non-deterministic polynomial, or non-polynomial, actually non-polynomial. Okay, so there are many problems that are now, so the P and NP, these are set, this is not a single problem, set of problems. So some problems that are now considered as P, in P, set P, polynomial, okay, that earlier those are non-polynomial. Previously those are unsolved. For instance, we know the sorting algorithms, right? They take polynomial time. Polynomial time, big O n squared or n log n, whatever it says. Okay, the searching time algorithm takes big O n. Okay, and then in best case, big O log n. Okay, and the finding GCD. Okay, and then finding prime numbers, Fibonacci numbers. These are all like deterministic algorithm in P. But there are some algorithms that cannot be solved this way. So these are called non-polynomial problems. Okay, so as I said that this problem, okay, for instance, and I said non-deterministic. Non-deterministic means deterministic. Let us say deterministic. Deterministic seems that whatever I'm writing, I know how it works. We know, and there are some definite steps that will follow it. But we know that what is the lowest or efficient? What is the efficient searching algorithm? Binary search, right? That it takes log n times, right? Okay, and linear search takes n time, right? Big O n times, right? And instead, compared to big O n time log n linear, binary search is better. But people still doing research, continuing research. Is there any way to find a constant time algorithm, searching algorithm? For instance, if an algorithm is like this, a search algorithm can be written like this way. Okay, so then search, you will use another method, maybe select, and then you will pass this parameter. Okay, main algorithm problem is search init algorithm, init item, and then from an array of size n, and then you will find the target value. So if you put the target value in a method called select, and the select method, it will give the index. Instantly it will give the index of that target value. Okay, then if it index, that index is available in the array, then we say that is found at index, this index, right? And if it is otherwise, it's not found. So these are type of algorithm will take, you see that in that case, this type of algorithm, so if this can be solved in constant time, then this will take constant time, right? And this will take constant time. So the entire searching algorithm can be solved in constant time. Okay, Now we are assuming that there is a method like select method or similar method, find method or some method that will give the index in constant time. But so far that does not exist. Okay, if it exists, then this problem will be searching algorithm can be solved in constant time. But so far it does not exist. But we can assume that, for instance, we say that hey, there is a function. Let us say that this function will give. Today we don't know how to write this problem, this method. But maybe sometime few years later some programmer can write this method. Okay, so today we don't know, this is unknown to us, so this is called non-deterministic. We don't know how it will happen. It is not determined yet. You understand? So this is non-deterministic, but so far we wrote our programs, everything is deterministic. If we even used a method, that method had body and implementation, but it does not have any implementation. We don't know yet. So this is non-deterministic. So there are, in other way, it is called tractable problem. P is called tractable, that we know that what is going on is called tractable or deterministic. And then if we do not know how it is going, then it's called intractable or unsolvable problem. Okay, so there are many problems in this world, those are still unsolvable, right? Still that are not solved, right? Can you tell us some problems that are not still solved? Any problem?
The traveling salesman.
Huh?
The traveling salesman.
What is that?
The traveling salesman.
Traveling salesman. Okay, that is a NP problem. Okay, yeah, traveling salesman. Then salesman one. That is good example. Okay, that is not solved yet. A traveling salesman, if wants to distribute or go into many cities, or for instance, let us consider a postman wants to deliver mail. Okay, in every house, all mails in every house, but he doesn't like to go one route twice, more than one time. But if the houses are not row houses, like they're scattered like this, is it possible for them? For him right now it's not possible, right? Sometime he need to go one more route, there will be a deadlock, right? There is a what is that called? Deadline, right? There is no exit. Then he has to come back. So then the process is failed, right? So this algorithm still is not solvable. Like in this world, as I said that this topic is not in computer science originally. Computer scientists borrow this problem. Okay, there's a reason that I will tell you that why the computer scientists borrowed this problem, other people problem. Okay, so now let us see that some problems. Okay, I asked you some problems that are not solved yet. We'll go that little, but let us see that recently solved some problem. Some problems. Let us see that are solved recently, maybe 2 years ago, 20 years ago, 200 years ago, 2000 years ago. Right? Let's engine. How many years ago engines are invented? A few thousand years ago, right? Few thousand years ago, right? Look at that. If when engines were not invented, then life was harder, right? People like the electric power. It is invented only a few hundred years ago, right? Think about that. When there is no electric power, there are many problems, right? And then when there is no battery, electric power or battery, when there is no telephone, and when there is no computer, when there is no internet, then there was many problems, right? And then when an engine is invented and our electric power or battery are invented, many problems are solved, right? So this maybe this has a revolution. Invention of electricity or battery is a revolution to humanity, right? Do you agree with me? Okay, this I told this class we want to make it collaborative. Okay, so the invention of this has solved many other similar problems. We know that one. But still there are a lot of unsolved problems in this world. I have a list, but let me hear your thought. Can you tell us some unsolvable problem? But there are some problems in this world still not solved, are not solved. It does not need to be necessarily in computer science or programming. For instance, for now, for the next 10 minutes, we forget about programming. We are thinking that any problem that is not solved yet. Tell me some problems.
Maybe that 3x plus 1 problem?
3x?
Yeah, it's this weird thing where like you start with some number and then you, if it's even, you divide it by 2, and if it's odd, you multiply it by 3 and add 1, and then you do the same thing over and over again. And the question is, or the hypothesis is that if you go on long enough, it'll eventually, like no matter what number you start with, it'll always end in a specific sequence.
I don't know. Okay. Can you please email me sometime with this example?
Maybe.
Yeah, we maybe
I don't
we can.
know much about it. I've just seen.
Yeah, that's good idea. So, but for now, I said let us think about very simple way, real world problem. We know not programming. Okay, for the next 10 minutes, forget about programming. We did a lot for the whole semester. We discussed about programming. Forget about it for the next 10 minutes. Tell me some real life problem. Yes.
World hunger, maybe? World hunger?
World hunger?
Yeah.
Yeah, that is a good problem. Why do we become hungry, right? It would be nice if we are not become hungry, right? Okay, there is one problem. Okay, traffic. Okay, then another problem, traffic problem. Why there are too many cars? Why it takes me 30 minutes to go to downtown? I could go in a second, right? Let me tell you another story. Now, is it possible to watch Second World War or the Civil War face to face? No, it's not as possible, right? But because how do we see an item, an object? When light reflects on an item, that reflex come to our eyes and we can see that, right? And we saw that in every second light passes how many miles? 186,000 miles, right? 186,000 miles per second light goes. Okay, so that means maybe a war happened 100 years ago. So that light or event passed 100 times the speed light. So for instance, let us see speed light speed calculator. Is there any? Is there any calculator? I don't know. Okay, speed of light. Okay, speed of light is this per second, right? And then we say time, maybe 100 years. Okay, and then we want to see distance, how far light goes. Okay, an event in 100 years ago, how far it goes. So this miles, meters, or make it miles. Where is that? Miles. It's a deterministic number, right? Still a constant number, not that much. Okay, so now if someone can invent an engine that goes faster than this speed, right? Then we can pass this distance, and then the light will come to our eyes, and we may see the event, what happened 100 years ago. But that is imaginary, right? So far we don't know that no engine can go this per mile. Okay. There are other problems in this world. Okay, so as I said, that I want to discuss from my perspective, on my understanding. Okay, don't think that I'm discussing politically or religious thing. That my goal is that to share with you how did I understand this concept. If you maybe remember this concept, if you understand the basic thing, you will never forget. And as I said, this is the most difficult thing. Many students, many people, they confuse. So there are many problems in this world. So let us think about a religious problem. Okay, many people. Some people believe and some people do not believe that. Whether there is a God, is there a single God? Some people believe, some people do not believe, right? Is there any unity in the whole world? No. With that question, there are some people believe there is a God, some people believe no. There is no God, we are created naturally. So then another similar question is there, are there angels? Are there heavens or paradise or hellfire? Similar questions, right? Some people believe, some people do not believe. Another question is, will we be resurrected for judgment? If there is a God, maybe he will create us again and he will judge us, right? Based on our action in this world. And some religions, people, they believe it, some people do not believe it. Similar questions. Is there another life after the death of this life? This is maybe $1 million question, right? Many people believe it, many people do not believe. Right? So these are the many real problems. Everybody will understand this is a very simple problem, right? So, but what happens if these problems will be solved? If these problems are solved, then many problems will be solved in this world. If I believe that there is a God, he will judge me, right? I will not make any crime. Right? Like whenever I go to a store, Walmart or very, very retail store, there are many items. I can pick an item and put on my pocket. I can steal it, right? Usually we do not do. Why? Why do not we do that?
Morals.
Two things. Morals. Morals means either ethical or religious morals. That I believe in someone is watching me, right? If I get this, I will be punished, either today or tomorrow or sometime later. Or some people believe that, hey, there is a camera. Right? If I'm caught, then I will get punished. Otherwise, if there is no this kind of fear, then maybe the whole store would be empty in one day. Right? So these are the problems. So like if we saw this, if source of this, any of this problem is solved, then those problems will be solved. Right? If we believe in this, then the whole world, all people in this world believe in these questions, then nobody will make any crime, nobody will kill another person, right? This earth will be heaven. We don't need another heaven, right? But we know that these problems are unsolved. Okay, but the NP Completeness says that let us pick a similar problem and to verify that problem, justify that problem. And if that problem is solved, then all of this problem will be solved. Or many of this problem will be solved. That is the NP and NP Completeness, the research idea. Main idea is that we don't see God, right? So since we cannot see angels, we cannot see heaven, we cannot see hellfire, we do not know if this is dead, another life after this death. So, but if we find another problem, so we cannot do this. So we cannot do any research on this, right? No one can do any research on this, whether there is a God or not. Cannot see. Why can what? We will not believe, right? So, but if there is a similar or another problem that we can work on it, and we can make any relation with that problem with this problem, then we will think that this problem are solved or can be solved. Okay, so this is just my own understanding. Let us see a similar problem like that. So all human, as a human being, right, how we born and brought up, grown up. We are a little baby, right, in our mother's womb, right, very tiny, and then become pounds, and then 2 pounds, 3.5 pounds, and then after 30 or 40 weeks, right, we born, and then we become babies, then infant, toddler, then schooler, and then sometime we believe that we are grown up, and we believe that sometime we will die. So all human being goes, all human people, human being go this sequence, right? Is there any doubt? There's no doubt in it, right? Now, it's completely my understanding. Let us see, whenever a baby was like this, maybe a 32 or 30 weeks baby, right? A baby does everything in his or her mom's womb, right? This is baby's world with a 1 square feet place, right? Or maybe how big a mom's womb? 1 square feet, right?
Could be.
Not maybe 2 square feet maximum. But a baby does everything. Sometimes you say that there are 2 babies, 3 babies, twin babies, right? And they do everything within this place. But did we hear that any baby complained? Did we ever complain that, hey mom, you did not give me enough space, I could not play, I could not move? We do not do that complaint, right? No baby makes that complaint, right? Okay. So at this position, at this situation, whenever you say that the baby is even like very a few weeks or few days, okay, do these babies believe in then there is another world? Or even this baby, does he believe that there is another world that is billion times larger than this world, this tummy? Do they know? We don't know, right? Maybe they know or they do not know, right? I like you to speak out. If I do something wrong, please let me know. So my understanding is that the baby, no one of us, we do not complain that we do not know that there is another world, this world, which is billion times larger. Here is airplane, ocean, then mountains, internet, computer, buildings, right? Bus, train. Okay? Okay, now, if possible, to teach this baby through any medical, now medical science is very improved, right? In many cases, medical science. I know my friend is in Atlanta. He before his baby was born, whenever the baby was 6 months in the sister's home, okay, a few weeks, maybe 20 weeks or something, doctor detected that baby's heart was not matured. There was a leakage in the heart. Doctor detected that here in Atlanta. And then doctor told the parent, my friend, that your babies need to be operation, they do a surgery right after the baby is born, on the same day, maybe same day. They mentally prepared. Okay, and then actually when the baby was 4 days, only the 4-day-old, they did a surgery, and then they put a canal to give milk. The doctor found that if the baby drinks milk, it will go to his heart. Then that will die. So then what they did an operation. They put a canal to give milk, and after when the baby was 3 months or less than 4 months, they did open surgery. And the baby is good right now, 2 years old. There is one thing that, and I read a newspaper many times ago that, long time ago, that some doctors, sometimes in some situation, doctors do surgery before the baby is born. Have you heard that? I read it, an article. Okay, and even I saw that practically. There are some babies, they watch YouTube or cartoon, just 6 months old. They know how to click on phone, okay, and then they know how to click on phone and watch video. Did you see that? A 6 month old baby, right? Okay, now if a 6 month old baby understand how to turn a phone, okay, and how to turn a video, or how to change a video, okay, then is it possible for the medical scientist to teach this baby that, hey, there is another world that is billion times larger than this little world, than your current world, and you will be soon going there. Okay, will this baby believe? Maybe yes or not, right? Some babies may believe. Okay, so that kind of research, if someone start, okay, so far we know it is not possible yet, but it may be possible in future. So according to the Np Completeness research says that, okay, if this problem is not solved yet, maybe some researchers started this research and they are teaching these babies that, hey, there is another world that is billion times larger than this world. Okay, like when we are taught, we are said that there is another heaven or hellfire. Okay, so but for instance, it takes this research a long time, maybe 5 years or 10 years to teach this baby, but by this time is 5 years or 10 years, 5 years, this baby will be the child, right? Will be school going by this time, so that if research is not effective, right? So if this research, Np Completeness research, tell that whatever times it takes, whatever the output, even it is not good enough, do not throw it out. Publish it and share with others. So that the next group of researchers, they will start, okay, for instance, a group of researchers, they take 5 years to teach this baby that, hey, there is another world. For instance, from Tamis, started from here, not here, okay. Although this research is not effective, I know that by this, with the 5 years, this baby will be grown up, and maybe some babies will understand, right? This is the world is larger. So we know that this research is not effective, but this research process will be published and shared, so that next group of people will start from there with the goal that, hey, those group of people take 5 years, let me do it in more efficient way, another way, so that it can take 2 years. Another people start from research, then, hey, those group of people took 2 years, let me do, they got 1 year. Another group of people start this research from 1 year, and they may at some point, maybe someone maybe will be successful to teach this baby before he born that there is another world, larger, real world. Okay, so that means whatever research is going, even it is not successful, but it is considered, it is valued. Okay, so now I brought this example so that now if babies can be taught there is another world like this world, and babies can remember this, then maybe all of us will remember that there is another world after our death, right? Maybe if this problem, or maybe a similar problem, the example I brought it here, maybe not right, maybe another problem, another way this can be taught to us, human baby. And if these problems are solved, like this problem is solved, some of these or many of these problems will be solved. And when some of this problem or all of this problem will be solved, many other problems will be solved, as I said, right? People will not make crime, people will not kill each other, okay? People will not steal each other's money and property. So this world will be a utopia. Okay, this is the main theme for NP completeness. That means whenever we say that there is a problem, okay, and that is not solved yet, don't upset. Okay, try to solve it. Okay, and whatever you can do it, share with it with others. And other people research will be benefited from starting from there. Maybe they will give better result. Okay, that is the NP completeness of. Now let me give some concept. There are terms. So that P means a set of problems that are solvable in polynomial or reasonable time. Okay. And NP problems are that are not solvable but verifiable. Okay, that are verifiable in polynomial time. Okay, and NP complete, then the term will come NP complete, are the hardest problem in NP. Hardest problem that cannot be solved. Okay, we believe that cannot be solved, right? For instance, we believe that whether there is a God or not, we cannot solve it because we cannot see a God. We cannot see the God, right? We cannot solve that problem. So starting that research is waste. Other than starting from something that is doable, maybe starting with a baby, with advanced medical science, that is doable. So what is doable, start from there. Instead of what is not doable, don't start from there. Okay, so now let us come. So there are many problems that are not solvable yet. Okay, that is called Hamiltonian path, Traversal salesman, that she brought this. Yeah, the salesman want to distribute all cities, but does not want to go single route twice. That problem cannot be solved. Okay, so now goal is that now let us back to in computer science perspective. So in computer science perspective, we know that there's some problems, algorithm, how to solve, sorting, searching, right? Now we have learned some algorithms. But you said that if you on less than 100 years ago, 90 years ago, there was a mathematician, his name was Turing. He discovered that in 1930s that there are some problems that are unsolvable by algorithm. Okay. Even many people, there are many people in this world who do not know computer science. They think that, hey, you are studying computer science, so you should do everything. You should solve. You should crack the password of my friend. Right? Did you hear that question from someone? Someone may ask, some of a relative maybe. Hey, you are good that you are studying computer science and programming. Yeah, you are good programmer. So solve this problem. Is it possible for you to solve all problems? No. Okay, but this is a valuable findings, a statement that people earlier thought that writing algorithm can solve all problems, but we know that it's not all. For all problem we cannot write algorithm. Okay, so there are many problems that cannot be solved. in this world right now. Okay, and now let us come back to the word. This is the word. So non-deterministic, understand non-deterministic? That means the algorithm, whatever you're writing, you don't understand whatever you're writing. And deterministic means whatever you are writing, you understand that you do some specific steps. Okay, so the NP algorithm are non-deterministic polynomial, okay, verification time algorithm, but this algorithm cannot be solved but can be verified. Okay, now let us come to some problems. So okay, so then this is $1 million question. Okay, is P equal to NP? P, so far whatever we learned, P is a set of problems that are solved, right? That can be solved in polynomial time, right? And NP are the problems that can be verified, cannot be solved but can be verified. So whatever problems maybe as if some problems there were in NP a few years ago, now they are in P. Still there are some problems that are now in NP. Okay, in future, next year or in next decade, okay, that will be solved and that will be in P. So day by day, time to time, P is growing and NP is shrinking. We are getting more solution, P is getting larger. Okay, P is a set. The element of this set is problem set is getting larger and larger. And then whenever a problem is NP, or originally it was NP, whenever it has a deterministic solution, it is no longer in NP, it is going to P. Okay, so that the question is that is P equal to NP? That means all non-polynomial program can be solved. Okay, we don't know yet. Okay, but we hope, and if it is, then many problems will be solved. And how do we do that research? The way is that we take some problems, or at least one problem. Okay, let me draw this on. One problem. Okay, let me try get another code. And there is another term is called NP hard. NP hard problem are the problems that are at least NP or more than or more complicated. If it is easy, then it is NP, or it is more harder. So you see the arrow, that means P problems are easy, like searching an algorithm, searching a number. Okay, searching a number in log n time, we know that there is an algorithm that is already determined. Searching a number in linear time, that is already determined, right? These are easy, but there are some problems still it's not the solution. Searching a number in constant time, it is not invented yet, this algorithm. So this is the hardest problem. So the hardest problem are called NP hard. Okay, and there is a term, you understand P, right? Is a set, not a single problem. And then we understand NP, right? Then we understand NP hard, and now the word is NP complete. Okay, NP complete problems, you see that there are the hardest problem in NP. It is verifiable in polynomial time, but it's very hard to verify. Okay, now some problems that are now NP hard, In future that will be in NP complete. In future that will be in P, or maybe in P, okay? So at some time P maybe will be in P. And all today the problem is verifiable, and someday it can be doable. There are some problems. Here today we can see moon, right? Maybe tonight is a moon night. We can see moonlight easily, right? But today now we cannot catch moon, right? We cannot go to moon in a few seconds. Maybe in future people can buy ticket, airplane ticket to go to moon. People will spend holiday in moon or in other planets. But still these are problems unsolvable to us, right? Okay. So there is a process called reduction. Reduction means if you are given a problem and that problem can be twisted or reduced to another problem that can be solved, okay, then a group of the third kind of problem can be solved. Okay, so in computer programming, now let us come back to NP and NP hard and NP completeness here in computer science. So in computer science perspective, satisfiability is a problem that is considered as a base case of NP problem, NP complete problems. NP complete means this is NP hard, but close to, it's pretty close to be solved. People cannot solve it yet. People is not successful, but still research are going. Hopefully it will be solved soon, right? Whenever you write a program, you reach a situation, right? I'm almost done, right? I'm not done yet, but almost done. You hope that if there is some minor issues, if I can solve this, then my assignment will be done. At that situation, okay? So there is a common problem, is a well-known problem. It is called satisfiability problem. Satisfiability problem is like this. Let me draw this. For instance, if you have some logical switches, maybe x1, x2, x3, x4, okay, and here x1 means this is 1, and this is not, okay, x2 not, that means this is 0, okay, and x3 means this is a 1, okay, and then here this is not, symbol is not, okay, that is not means, for instance, 0. And here actually it can write this way, x1, this is logical OR operation, okay, or x2 not, okay, and this is and x3, okay, or this is or x4 not. If you are given an expression, Boolean expression like this, and you are asked to find for which of this combination, for this there are 4 circuits, right? All of this can be 0. Some of this can be 0, some of this can be 1. Okay? Some of this can be 1. So total how many combination will be? For 4 circuit, 4 switches, how many combination will be?
16.
Yeah, 2 to the power 4, right? So 2 to the power 4 there will be 16 total combination, right? So this satisfiability problem says that from these 16 problems, for this 16 combination, tell me which combination always make this true. Always make this true. This is Boolean, true means 1, right? Tell me the combination of these x1, x2, x4. For which combination this expression will give always 1. Maybe some of this will give 1, right? We don't know yet. Maybe 1 or 2 of this combination. We are among these 16 combination. What we can do, we can check 1 by 1, right? Using this 4 combination, we can check 1 by 1. Does this combination gives 1? Does this combination give 1? Does this give 1? Does this give 1? Total we can do 16 combination. And through this 16 combination, we can check, hey, this one is always give. This one gives 1. Right? So for x equal to 4, how many combination we get? 2 to the power 4, right? Then for n of this circuit, if I have n this logical this instance, then how many will be? 2 to the power n, right? The complexity will be big or 2 to the power n, right? A non-deterministic problem, NP, right? So now that means we see that this problem, satisfiability problem, is a NP problem. So now our goal will be to correlate this problem with any known P problem, with a problem that can be solved polynomially. Is there any real algorithm that can be related to this? Is in P. Okay, is there any related to this in P? Do you know that some I hear that for some twins babies, okay, if someone gets sick, another one gets sick. Did you hear that? For twin babies, or twin sister brothers, if someone gets sick, another one also gets sick. Usually we see that our parents, they give same kind of dress for twin babies, right? Most of them give same color and okay. So like if I have a good friendship with you, okay, the friendship is so bosom that if someone hit me, you will get some pain, okay, or someone hits you, I will get some pain. And if that is always true, right, then if my problem is solved, your problem will be solved, right? So this kind of imaginary, we know that this is imaginary, it's not problem, but we are doing research on this. This is called Np Completeness research. So we know that this algorithm, satisfiability algorithm, we see that this takes polynomial time in Np, right? Is Np, non-polynomial times, okay? It is. But do you remember that is there any algorithm that was previously like this, but now it is in previously in P, in Np, now is in P? We recently discussed a few weeks ago or last week, or this week, discussed an algorithm that was previously non-polynomial, non-deterministic, but now it is deterministic. Do you remember that algorithm? We just discussed last week, this week, last class.
Fibonacci?
Huh?
Fibonacci?
No. Last lecture we discussed an algorithm that was in NP for a long time, but now this is in P. What algorithms we discussed in last lecture? 2 algorithms, right? One was matrix chain multiplication, another was 0-1 knapsack problem, right? So 0-1 knapsack problem says, so this is satisfiability problem. This is satisfiability problem. And 0, 1 knapsack. Problem that there are some items. Okay, there are some items. Item 4, maybe item 3, item 1, item 2. There are 4 items. Which one of you select? Which one of you select, or to get the maximum profit or benefit, right? And without using the dynamic algorithm, it took 2 to the power n, right? It took 2 to the power. Without using dynamic algorithm, that took 2 to the power n. But with dynamic algorithm, it took big O mn or m square or n squared. So that was previously before the invention of dynamic programming. For this solving this one, it was non-polynomial. Okay, but now with the invention of this polynomial, this is polynomial. Now it is polynomial, right? Now if we know that, if we can do, that means if we can solve, we can correlate this satisfiability problem with this 0, 1 knapsack problem. In such way that this can be, since 0, 1 knapsack problem can be solved in polynomial way, also this can be solved in polynomial way. Do you understand what I said? If we can show that there is a relation, such relation that this kind of problem can be converted to this kind of problem, then we know that this kind of problems can be solved in polynomial time. So this can be solved in polynomial time. Right? So we say that satisfiability symbol is used, this symbol, epsilon symbol, proportional to, okay? That means if this problem can be solved, then this can be solved. Or if this can be solved in polynomial time, this can be solved in polynomial, or at least verified. Cannot solve, if we cannot solve, it can be verified. Do you understand this? Okay, so this is difficult. Maybe some people confused. But if you, the anecdotal example I gave you, teaching a baby if there is a world like this, okay? Similar, think about that way. As we saw that if we can teach babies that there is a world here, in this world there is a jail. If you do crime, you will get in jail, right? They're police, they're army. And similarly, maybe all of you believe whether there is a life hereafter, or there is a God or not, or something like this. Similarly, if one problem can be solved, and there was non-polynomial, but can be, and another problem that is now polynomial, and another problem it can relate. We see that there is a relation, right? This problem can be related to same thing, 0, 1 this combination, and also this is same combination. So satisfiability problem, it is considered as the base case of non-polynomial problem, or the NP hard problem. Okay. For instance, as I said that, for me, it's my understanding, I may be wrong, but it's my understanding that is as I believe that, as I think that if these babies, all babies can be taught, there is another world here. Similarly, maybe this many of this problem will be solved. Many of this problem will be solved. And all, if that problem will be solved, many other problems will be solved. Right? People will not do crime, people will not do kill each other, people will not do fight war. Okay? So what do we do? The research does, it seeks for a base case. Some problems that can be correlated with other problems. So since this research is a continuous research, no one can solve alone this problem. Maybe a group of people will spend years after years and they will get some outcome. At the time they will die. Another group of researchers will start from there. Okay, so NP completeness here, let's see. NP hard problem that are not solvable. For now, for instance, think about that, are not solvable. But if a NP hard problem can be maybe it's not solved, but close to be solved, right? Whenever you do an assignment, even if you cannot complete the assignment, if you very close, you get point, right? It's 80%, 90%, 85% point, right? So better than nothing. So if you do not submit your assignment, say I could not, my program did not run, right? Or if you say, Professor, I tried, that I did this up to this, then this is still better, right? So whenever an NP hard problem can be verified and can be solved or be written like an NP problem. You see that NP problems are not solvable polynomially, verifiable. Still it's not solvable. Okay? Verifiable or predictable or given an idea, this is the way I can solve this problem. Okay, so this is called NP completeness. And why this is a research area for many subjects, not in computer science? Because this problem actually originally it was not from computer science. This was in math and other problems. Math, religious, politics, business. Okay, all other things, for instance, they have NP completeness. And what they're doing, the people are doing research collaboratively. Think about that. How we call say satisfiability problem if there are x1, x2, x3. This actually you will learn this. This is not a one day topic. Okay, if you read now, I think you got a basic idea, right? Even whenever maybe 20 years ago, 5 years ago, I was a student like you. Our professor taught that we didn't understand what he's saying, professor. But later, many times later, whenever I was able to get an example, real life example, that what is an NP problem that was previously unsolved, or NP hard problem, or NP problem, like the invention of electricity. Sometimes a few hundred years ago, electricity was not invented, right? That was unsolved. Now, whenever electricity, now it is solved. And whenever an electricity is invented, many things are being invented. Many problems are solved. Whenever computer is invented, right? Many problems are solved. Before the telephone, when telephone was not available or invented, how people communicated? Right? In life was not easy, right? Now we have electricity. We're lucky that we live in good weather, right? We can control our temperature in room even if it's snowing outside. But think about that 500 years ago when there was no electricity, no gas, natural gas, how people lived. How our great grandparents lived, right? They lived a miserable life, right? Right? And compared to their lives, our life is easy. All of these are effect for this research, this kind of research. Okay, and we don't know yet that what will happen after 50 years. You know, when I was a student, computer science student like you, 25 or 25 years ago, even we did not, taught telecommunication. We took telecommunication course, and at that time the research on mobile phone was only in initial phase in some countries. And also at that time, even we did not think about the smartphone, touch phone. I did not see any research on that time, 30, 40 years ago. Now, our babies see smartphone, right? 6-month-old babies see smartphone. He uses. And what happened after 50 years? Imagine. Even we cannot imagine, right? So our children and our maybe grandchildren will be enjoying more, right? And now whenever we are going back to home after this class, maybe we have to drive maybe an hour, 30 minutes, 40 minutes. Maybe after 50 years, they don't need to drive. They will fly from here to home. Okay. Okay, I spent a lot of time. So now, as I said that, whatever I discussed and then the examples, I brought this from my own understanding. And now if you start reading this chapter, books or related papers, journal about NP completeness, then you may get your own idea, own examples. Okay, as I said that, for instance, electricity, computer, telephones, internet, these are recently solved problems, right? To me, you may find another set of recently solved problems, right? In another domain, maybe medical domain or business domain, other domain you can see. So find a set of problems that is recently solved from your own, okay? And find another unsolved problems, your own. Find your own, make a list of unsolved problems that you think that is not solved. And try to think that from this problem, which can be started with to do research, right? For instance, for me, we cannot see God, we cannot see heaven, we cannot see angel, okay? We cannot see how the judgment will be, so we cannot do any research from that. But whatever we see, that we know there are babies, every human being born this way. So some group of medical people, medical students, they may reach a professor, they may start research from here. This is doable, right? Similarly, bring your own set of problems and correlate that, start research from there. Then you will be benefited. Maybe if you are not benefited, maybe your next generation will be benefited. So this is a good, interesting research topic, research area, okay? Some of you may be interested in doing this. Does anyone has any question? Did I tell something wrong? Adam.
Good.
Did I tell something wrong?
I'm sorry?
Did I tell something wrong?
No.
Okay. I may be wrong, but this is the way I understand this topic. Okay, I have uploaded this lecture. Next slide. Okay. Does anyone has any question about the test? Next assignments or next quiz. Okay, so there is one more quiz and assignment left. I will post it in the during this semester break, and then you will get time after the semester break to quiz. That will be optional. If you do not take it, it's good. But if you take it, then your lowest quiz and assignment grade will be dropped. Okay, so I like you to take it. Okay, but there is no penalty if you do not take it.
And when the next test?
So I think this is our last class. And then after that, if we need to meet in, let me know. Okay, and then that's the review week. Other we can meet. We may meet online. If there is any discussion, we may meet online. Okay. Or if you really think that there is something that we need to meet face to face, please post that in Teams app so that everybody knows what is your thought or what is your problem. Okay. So now, I believe I tried my best to share with you whatever I understand, but this is really a difficult course. I did not have any GA, nothing to help me. We all have to do everything. So it is really difficult to teach 2 sections. I have another 2 sections without any GTA this course. Okay. Give me 1 more minute, please. I will take attendance. And thank you so much. Well, the evaluation, teaching evaluation is on. Okay. You can evaluate or you have your own judgment, but I tried my best. And I hope you will give me positive feedback. Okay. Thank you.